Today we are going to discuss another problem from square and square root. The question given to us says that Amit walks 16 meters south from his house and turns east to walk 63 meters to reach his friend's house. While returning, he walks diagonally from his friend's house to reach back to his house. Now, in order to find the solution to this problem, first we have to understand the basic geographic directions. There are four main geographic directions: north at the top, south at the bottom, east to the right, and west to the left. So these are the basic geographic directions that we are going to use. And we are going to draw a simple diagram to actually understand what we are asked to do. Amit walks 16 meters south from his house. So if here is Amit, he is walking 16 meter to the south. South direction is this, and this he is walking for 16 meter. After this, to reach and turns east. After he walks 16 meter from his house, he then turns east. So he is then turning east. So this is the direction he is taking, and he is walking 63 meter in this direction, east direction. Okay. Now, after this, while returning, he walks diagonally from his friend's house. So here, after he reaches at this point, here is where we find his friend's house. So here is his friend's house. From here, he walks back to his house. His house was here. Originally, he was walking from his house. So here was his house. He walked 16 meter to the south direction and then 63 meter to the east direction, and while returning back to his home, he took the diagonal path. Diagonal means this. So this is the diagram we were asked to form. So first, this is what we had to do. Now see, we have got two parts of the triangle and we need to find the third part of the triangle, and this resembles a perfect 90-degree triangle. So you can see this is a 90-degree triangle. So we have to first understand the parts of a triangle. This is called the perpendicular. P for perpendicular. This is B, that is base, and this is called the hypotenuse or H. In order to find out the third side of a right angle triangle, we use the Pythagoras theorem. So we are going to first write down what is the Pythagoras theorem. By Pythagoras theorem states that hypotenuse square is basically the summation of the base square and the perpendicular square. So this is what is our Pythagoras theorem. And we are going to apply exactly this formula in order to find out the solution. Now see, we already know the perpendicular, that is 16 meter, and the base is 63 meter. So in the place of base, we are going to write here, substitute with the value 63 square. For now, we may omit and not write the units right now. We are going to write it finally at the place of the answer. Here the P, that is perpendicular, is equal to 16. So we are going to write 16 square here. Now as we have got it, this will be, after solving this, we are going to get hypotenuse square. 63 square is 63 into 63, that is 3969. So this is 3969 plus 16 square is 256. So 256. We've written it. Now 256 plus 3969 is 4225. So now we're going to write 4225, and this is the answer to h square, that is hypotenuse square. So now we have to find the square root of the number. This is hypotenuse square. Therefore hypotenuse will be the square root of 4225. So we're going to solve it. Follow the steps simply. 4225. Think of a number which is a square closest to 42. So it's going to be 6 6 is 36 because 7 square becomes 49. So we're going to use 6 now. So 6 into 6 is 36. Subtract the number. Get 6. Then the 25 moves down. This 6 will be multiplied by 2 as we know. And we're going to write it over here. 1, 2. And think of a number in this position with which if we multiply, we get 625. If we are well versed with the table, we would know that 125 into 5 is 625. So here we are going to write 5. I'll show you. See? And here also 5. See? 125 into 5. See? It's 625. So that is what we have used over here. So we have got the perfect number. We'll subtract and nothing leaves as a remainder, which means 65 square. So we can therefore write that h is equal to 65. And therefore we were asked to find the distance he walked while returning. So we're going to write the statement, therefore distance he walked while returning is equal to this answer, 65 meter. We're going to write the unit this time. That's it.